Hello community! We have a beautiful new chain of thought called Self-Harmonized and some great code implementation for you. And here we have it, September 6, 2024, Self-Harmonized Chain of Thought. And you might say, wait, is it the same chain of thought that in 2022 was already introduced to us by Jason Wei? Yeah, of course. And then you say, but then 2022, 2023, we had here the automatic chain of thought prompting, where the auto chain of thought automates here the process of creating here our demonstration by employing here a zero-shot CoT, and then it clusters those questions based on their cosine similarity in the vector space and selects a representative question from each cluster. Yes, this is auto CT that we're going to talk of. And remember how easy it was to code, because we just said git clone auto CoT git, and then we had it available, and then we just had one line and we got here a beautiful chain of thought. And remember in March 2023 where we had this self-consistency that improves here our chain of thought methodology. And here Jason Wei is here the second author, and you see this is now interesting. But you know, I introduced you here from September 5th, even the latest, the strategic chain of thought, where we have guiding accurate reasoning in LLMs through a strategic way. But now we focus here on September 6th, one day later, and we have a self-harmonized chain of thought, and let's talk about this. Now the nice thing is we have a lot of data for the evaluation of this, so all the datasets are available for you, the code is available for you, you can run it immediately, this is beautiful. You just go there, you define what you want to use. For example, if you go with a dataset common sense question and answer, and you go for a very cheap one, GPT 3.5 Turbo, whatever you like, the number of clusters and the iteration for Echo, and you just run it and you have a beautiful code. Now, if you say, hey, can somebody explain this Python code for me? Yes, of course, AI can do it. And as you see, I used the GPT-4 Omni because I do know nothing about code. And I said, hey, explain this code for me. And GPT came, so, you know, at first you import the libraries. And I said, ah. And then I said, yeah, then you pass the argument to the function. I said, ah. And then it came and said, hey, yeah, no, then we define a main function for this. And then you save the results. And I was blown away if I would not have known this already, because I do have here a playlist on YouTube where I have 40 videos showing you how to use a sentence transformer and how we code it, how we pre-train it, how we do the complete theory. And you might say, this is all? No, there's not all. I have here fine-tune here, a FLAN T5 LLM, and then I showed you how to do the training dataset, and I have here a complete YouTube playlist how to generate the dataset for this. And if you like to do a crossing code, a zero-shot question and answer with a sentence transformer expert, I showed you here 3 further videos how to do this, and there's more on my YouTube channel. And you might say, okay, but let's come back. So we have auto chain of thought generates here a new rationale for each chosen question. Now, you know, chain of thought here, the auto version has one problem. And this challenge is known as the misleading by similarity, as the method depends on the demonstration initialized by our zero-shot chain of thought. So this means if one of your demonstrations, one of your training data may have an incorrect reasoning process, or maybe it is not really perfect for this particular reasoning chain, the logic chain, you got a lot of problem, because if one of those, let's call it wrong or not optimized demonstration, happens to be similar to the problem that you would solve in your task, you have a misleading logical causal reasoning chain, and then it goes downward from this point on. So now we have here, September 6th, a novel method that aims to unify here the rational patterns here. And how it's doing this, it generates a general pattern, which is the balance point between all the other patterns in our causal reasoning chain. And you say, this sounds interesting, and it's called ECHO, and it stands for Self-Harmonized Chain of Thought. So let's have a look at this. There's a 3-step approach, and I make it real simple for Echo. First, split a given dataset into several clusters and select one representative question from each cluster. Standard, you know how to do this. Second, use a zero-shot chain of thought for each question to generate its rationale, its causal path. Third, employ a dynamic prompting mechanism where demonstrations can be improved by each other. Now it gets interesting. So in this step, one demonstration is randomly chosen to regenerate its rationale at each iteration, while the remaining demonstrations serve here in our prompt as an in-context learning example. And you understand immediately where we are. This process ensures continuous refinement and adaptation of our reasoning pattern between the demonstration in the different clusters. If you say, I got it, beautiful, completely understood the idea, ignore the next 3 minutes because I show you here for my green grasshoppers, step 1 in detail. What I mean with clustering the dataset. You have a given dataset, I will show you one in a second, and your first step involves splitting a given dataset into several clusters. And instead of treating all the questions in the dataset as independent to each other, we group them based on their semantic similarity. You know how we do this? Yes, we have a sentence transformer, S-BERT or Sentence-BERT, or how I like to take this. And it just generates here a high-dimensional 1000-dimensional vector space to represent each question as a vector in this high-dimensional vector space that is very particular to the knowledge domain that you're working in. Because the way it is built, please see my 50 videos on S-BERT, is really crucial for the quality of your answer. So this vector embeddings capture here the meaning of the question in a way that similar question will have vectors close to each other, and you got it. We have a cosine similarity, apply a clustering algorithm, go with the simplest of k-means, or do some hierarchical clustering to divide the question into groups, into clusters, based on how similar they are. And each group contains questions that are now semantically related. And this is only true if you're really careful, if you really think about how to create the dataset, and I have several videos on this. And after clustering, you select one representative question from each cluster. So this representative question is chosen as the most typical or the central question of this particular singular cluster, and it will serve as the basis for generating a reasoning chain, or we also call it a rationale for that particular group. Step 2, generating rationales with zero-shot chain of thought. So for each representative question selected here in our step 1, now you generate, the agent, the LLM generates a reasoning chain, a rationale, using here zero-shot chain of thought. Very easy, you provide the model now with the famous prompt. Let's think step by step without showing it any examples of how to solve similar problems, and the model generates reasoning directly for the question, breaking down the solution into intermediate, less complex task steps. So, simple question. If Tim has 5 apples and gives away 2 apples, how many apples does he have left? Now, the classical zero-shot chain of thought should be able to solve this. Tim has 5 apples, he gives away 2 apples. The third step is subtract 2 from 5, it's 3, therefore Tim has 3 apples left. And this process is now done for each representative question in each of your clusters, resulting in one rationale per cluster. You have an idea of how it goes on? Yes, of course. Step 3. Now, the core innovation of this new methodology ECHO is it applies a dynamic prompting mechanism to improve the quality of the reasoning chain over time through continuous refinement. How is it done? Well, have a look. At each iteration, ECHO selects one demonstration, one rationale randomly, and regenerates it using the other rationales from the other clusters as an in-context example. So we have ICL learning. So one reasoning chain, a representative question from cluster A, is chosen at random. And this reasoning chain is then regenerated by the model, by our LLM, but this time the model is shown other reasoning chains from cluster B, from cluster C, as part of the prompt. So these other chains act now as guidelines or hints to improve the current reasoning. It is simple and in-context learning. So in GPT-like models, in-context learning examples influence now the reasoning process by showing the model other rationales while generating the new rationale, and therefore you allow it to learn from those examples and adapt its reasoning based on the patterns it sees now across different reasoning chains. So you see, It's a continuous cycle. If you have cluster A, B, C, D, whatever cluster you have, it continuously learns from the other clusters. Let me give an example from a dataset. Here we have a dataset, and let's make it a little bit easier. Now, the question is, what do people aim to do at work? So this is here our training dataset, if you want. And now we have options. No? You have, for example, here label C, to kill the animals, or the label D is to wear hats, or label E is, hey, to talk to each other. Now, we have here the answer key. The answer key is now A, and you see the correct answer to what people aim to do at work is now complete the job. However, if you look at this, you understand it does not kill animals or wear hats, but to learn from each other would also be an option, or to talk to each other, therefore communicate and therefore be able to learn from each other to complete the job. And you immediately see the sensitivity of your data set, where you have here now, if you want, the training causality chains that you provide for the system to learn. I'll give you another one for my grade school math test. James decided to run 3 sprints 3 times a week. He runs 60 meters each sprint. How many total meters does he run in a week? And the answer is given. So you see, from this kind of data set, now our AI agent, our LLM, try to make sense in its reasoning pathway. And just to show you how this is in our particular example, grade school math, you have 1,319 examples. Here you see, this is here, each line, one example with one answer. Now you might say, let's think a little bit about this particular thing, because remember, this paper with the self-harmonized chain of thought from September 6th is not so different from the strategic chain of thought from September 5th. And do you see why? And you find this here in my video I called Reflection 70B, what happened? Here, this is the second part of the video where I show you strategic chain of thought. Because the complexity in the given solution in the data sets by the self-harmonized, they generate kind of a strategy for a specific solution in a particular domain, and let's say the domain is mathematics. This is now a purely personal idea. This is not published. This is not part in any of those papers. This is just me, because I think, hey, if this AI agent here in ECHO succeeds, it can deduct here from those examples a mathematical formula for given problems. And I have here 1,319 problems, and each problem or each question has an answer that is more or less a mathematical formula. So the beauty now of this is why we do ECHO. Let's start with this one. How does it improve here our auto chain of thought? Now, we have cross-pollination of the reasoning patterns. And I think this is the main part, the main new idea here. Because the model regenerates rationals by leveraging other demonstration, reasoning patterns from one cluster, they can improve those in the other clusters. And you know, the beauty is, if one reasoning chain misses now a crucial logical step in one cluster, another chain might help fill that gap by providing a similar but more complex explanation from another cluster. So think about different clusters, and in the clusters you find common denominators, maybe common mathematical formulas. So this is nice. This is kind of a self-learning system where you have a dynamic adaptation. Because this process is iterative, and this is a simple parameter I can set here in the Python code. I go here with 12 normally. So each iteration randomly selects a different rational to regenerate. All the rational get a chance to be improved over time. And each rational, each causal chain is continuously influenced by others. So this leads here to this, what they authors call a harmonized set of reasoning chains. And this is nice because, as I've shown you in a pure auto chain of thought, if you have one error, one mistake in a logical chain, It is there. It is imprinted on your causal logic. But here, with this continuous check with the other clusters, you can, let's say, get rid of this particular single error because you have a continuous refinement. Now, of course, the authors here of this paper here did not know that you and I, we are so beautifully intelligent that we immediately understood here the principle. So they give us here figure 2, they give us here the overview of the ECHO method, and they say, you know, there's this rationale and other demonstration and give them in as in-context examples. They have no idea how clever we are. Now, for my green grasshoppers, a very simple example. Let's say you have 2 representative questions. In a cluster A, we have the example, hey, if Tim has 5 apples and gives away 2, how many apples does he have left? And cluster B, if Sarah has 7 books and gives 3 books to a friend, how many does she have left? Now, for cluster A, the model might generate now a reasoning chain that goes as follows, 3 steps. Tim has 5 apples, gives away 2 apples, subtract, so Tim has 3 apples left. For cluster B, the model might generate now 7 books, gives away 3 books, 4 books left. Now in the next iteration of ECHO, it selects now the cluster A rationale to regenerate, but it is also presented here with the cluster B rationale as a solution, as an in-context example to learn. So the model might now, the LLM might now notice that both problems in cluster A and cluster B involve subtraction, and improves its reasoning by refining how it breaks down the task, ensuring that both reasoning chains in A and in B follow a consistent step-by-step pattern, ABC, ABC. And a consistent step-by-step pattern, you know what this is? This is simply a list of specific actions. And do you know what a list of specific action is also called? A strategy. And therefore, quod erat demonstrandum, those 2 papers in my mind are really similar. The strategy chain of thought implies that our AI agent has learned a strategy like a mathematical formula already. But now here in this other chain of thought, this harmonized chain of thought, you provide here the agent with so many training data that the agent is able to deduct here, let's say, mathematical formulas from the given examples. Exactly this. So you understand those datasets with this ECHO method, they are so crucial because all the intelligence and all the causal logic that at a specific complexity level, and I suppose you start with low, you're going to go to middle, and then you have a high complexity level. Those 1,300 examples, they better be damn good. Otherwise, you will not have the optimal performance. The performance benchmark. The authors did a beautiful performance benchmark. They give us the code. You can run this, have a look at it. This is the result. You see here for 3 general tasks, arithmetic tasks, common sense, question and answering, and symbolic logic, whatever. And they give you here 3 systems. A few shot chain of thought, the classical one. Then the auto chain of thought from 2022, 2023. And this new methodology from ECHO. And let's make it a little bit clearer. So green, it outperforms. Red, it is not the best model. So just looking here at the last line, you see it's kind of a mixed bag, no? The performance. And this is here from the official publication. So therefore I would say interesting. So what is the overall improvement if you compare this to an auto chain of thought or to a manual or a human instructed few-shot chain of thought? And they give us here, our approach outperforms the auto chain of thought by an average margin of 2.3%. Now let's be clear. If the complete benefit of this methodology, where you have to design the datasets in a very particular way, in an ascending complexity level, to incorporate your causal reasoning chain in examples given and you have to provide hundreds or thousands of examples, and the overall benefit of this is 2.3%, this is an interesting statement. I think you and I, we should know that this is what the authors published as the outperformance over a auto chain of thought system. But do you know what? Because we know everything about the complexity of vector spaces and how we build our hyper-tuned sentence-BERT systems, we know now, after 50 videos and coding hundreds of datasets for sentence-BERTs and creating those very specific vector spaces for causal reasoning for logical chains, we have both, I suppose, a new idea how to improve this for a very sharp domain, for a very narrow defined domain experience, let's say theoretical physics, where we could theoretically, if we do not have already, let's say, a simple mathematical formula, but where the system has to come up, our multi-agent system, AI system, has to come up with a new formula, with new insights, with a new complex pattern, then I think this methodology, this will be really interesting. Because imagine you're at CERN and you have a lot of observational empirical data, but you don't have yet now the complete theory behind this. This will be a question: is an AI system, given millions and millions of events, is it able to deduct a logical pattern that would explain all the experiments done at a particular site? So you see, AI is fascinating. And even if a paper tells you, hey, we achieved 2% improvement, never mind. If you understand the logic behind this, if you understand the tools they use, if you understand the process, how they apply this, and you really understand it, you immediately understand how you can improve on their system, how you can use this, apply this, deploy this in your professional domain, and maybe you have an idea how this might be really beneficial. So AI is fascinating. It would be great to see you in my next video.